Here let us discuss about crystal field stabilization energy. It is the amount of stabilization, okay, the amount of stabilization provided by the splitting of d orbital, okay, into two different levels. One is Eg and the other one is T2g. In our previous video we have learned for octahedral, okay, the d orbital splits into Eg, where Eg is raised to a higher energy and T2g is, okay, has been reduced to a lower energy. Okay, now for Eg set, the splitting energy is 3 by 5, which is equal to 0.6 delta 0, okay, or O. Then 2 by 5, the delta 0 is equal to 0.4 delta 0. Here, since the energy has been increased in case of Eg set, therefore it will be plus 0.6 delta 0, okay, and for the T2g set it has been reduced, okay, the energy has been reduced by an amount of, okay, since it is reduced, therefore it will be negative by an amount of 0.4 delta 0, okay. Now here the negative sign shows that the orbital, okay, the T2g set of orbital is more stable compared to Eg, okay. So now let us find out how to calculate Cfsc, okay. In case of tetrahedral it will be just the opposite of this one, okay. Now let us calculate, okay. So for calculating the Cfsc of different d orbitals, okay, of different d configurations. So d1 is there, d2 is there, d3, okay, d4 and so on up to d10, okay. Now for the first set, okay, for the first 3 d configurations, that is d1, okay, in d1 according to the octahedral splitting it will be T2g and Eg, okay. For d1 the electron will be filled in T2g, as you can see here, okay. This is T2g, this is Eg, okay, Eg. Now it doesn't matter whether it is a low spin or high spin complex, okay. So the electrons will be filled first at a lower energy, so it will be filled in one of the T2g orbital, so that is here. Now you see total number of electron which is in the T2g set of orbitals. So in T2g it is minus 0.4 delta 0, okay. So the stabilization of this one is 1 into 1 means 1 electron into minus 0.4 delta 0 equals to minus 0.4 delta 0, okay. So this is the way we calculate the Cfsc, okay. So see, for d1, d2 and d3 type of configuration, see, if it is d2 then 2 electrons will be there, if it is d3 3 electrons will be there, okay. So it doesn't matter whether it is a low spin or high spin, the stabilization energy or the crystal field stabilization energy calculation will not be a difficulty one, okay, because we don't have to look whether it is a high spin or low spin complex. But for a d4 configuration, let us see how it is, okay. For d4 configuration, see here there are two chances, either all the 4 electrons will be in the T2g set, or it can be also be filled in the Eg set of orbital, okay. So here low spin complex and high spin complex comes into play, okay. So the this is d4, okay. So for low spin means less number of unpaired electrons, okay, less number of unpaired electrons. Therefore this low spin is caused due to the strong field ligand, okay, and therefore the energy gap between the Eg and T2G will be much higher. Therefore, the electrons will be filled only in the T2G level, okay. So the configuration is T2G and Eg, okay. All the 4 electrons will be filled in the T2G because it is low spin, means less number of unpaired electrons, okay. So in the T2G there will be 4 and Eg there will be 0 electrons, okay. So now Cfsc is, you see, Cfsc equals to, in the T2G set, okay, 4 electrons are there multiplied by the energy, that is minus 0.4 delta 0 plus, okay, 0 into plus 0.6, okay, this one will not make any sense. So this one will go 0 and here it will be 4 for the 16, so it will be minus 1.60, okay. Now the negative sign Fi, as I have already mentioned, that it shows the stability of that particular complex. The higher the number of the negative value, okay, the higher it goes, the more will be the stability of that particular complex, okay. Now let us try for high spin, okay, let us try for high spin. High spin means more number of unpaired electrons, okay. So in case of high spin, what happens, this is Eg, this is T2G, okay. For D4 system the configuration is T2G and Eg. Now in a high spin it is caused due to the weak field ligand, okay. Weak field ligand does not create huge gap, or the splitting between the two set of orbital is not large, okay. Therefore the electrons can be filled even in Eg set of orbital, okay. So the 4 electrons here singly, then here will be the 4th electron. So in the T2G set of orbital 3 electrons are there, in Eg there is 1, okay. Now the Cfsc is equal to 3 into minus 0.4 delta naught, okay, plus 1 into plus 0.6 delta naught, okay. So you calculate this one, 3 4s are 12, 2 plus 0.6 delta naught, okay. So this will give you, I think, minus 0.6, okay. So this is how we calculate the Cfsc for different D configurations, okay. Now I want you to try by yourself for the remaining D configurations, okay. So leaving aside D1 and D4, okay, you try for the remaining type of configuration for both low spin as well as high spin, okay. As I have said that for D1, D2 and D3 it does not matter whether it is low spin or high spin, okay, it will have the same energy for both type. But from D4 onwards the stabilization energy or Cfsc value will be different, okay. So I want you to try the remaining D configurations, and if you can try even for tetrahedral, this is for octahedral, okay, you try it for tetrahedral also,